for humanity. We have to consider this possibility. We have to get as much data as possible. It's possible that this object is just a comet. That's the most likely situation.
What happens when a Harvard astrophysicist refuses to play it safe? What if alien technology and interstellar visitors aren't just science fiction, but possibilities worth testing? Could the universe already be sending us evidence? And are we brave enough to look for it? Avi Loeb isn't your typical astrophysicist. He's the Harvard professor who's made a career out of challenging what we think we know about the universe. An Israeli-American theorist, he runs Harvard's Institute for Theory and Computation, helped found its Black Hole Initiative, and once chaired the entire astronomy department. His credentials are stacked. Fellow of the American Academy of Arts and Sciences, the American Physical Society, and the International Academy of Astronautics. He also directs theory for the Breakthrough Initiatives, one of the biggest programs searching for life beyond Earth.
What lies outside the solar system is my day job as an astrophysicist.
But Loeb is best known, and most controversial, for his claims about alien technology. Since 2017, he's argued that interstellar objects like Oumuamua and CNEOS 2014-01-08 could be artificial rather than natural. In 2023, he even announced his team had pulled metallic spherules from the ocean floor linked to one of these objects. Many scientists dismiss his conclusions, pointing to shaky data, but Loeb refuses to back down. To some, he's chasing headlines. To others, he's the rare voice willing to ask the questions no one else dares.
And speed showed something completely different. By October 22nd, we had enough data to realize that this object wasn't from our solar system.
The Galileo Project, launched in July 2021 by Avi Loeb, with backing from Frank Larkian, is one of the boldest attempts yet to seriously hunt for signs of extraterrestrial technology. Its name is no accident. Just as Galileo Galilei once pointed a new kind of telescope at the heavens and shattered centuries of conventional wisdom, Loeb's project is trying to do the same in our own time. The mission is simple but ambitious. Look for evidence of astroarchaeology, possible relics, artifacts, or even active probes from other civilizations. And unlike most efforts in this arena, the Galileo Project doesn't start with assumptions. It promises an agnostic, data-first approach, letting the evidence speak for itself. The scope is wide. The team is investigating interstellar objects like Oumuamua that may not fit neatly into natural explanations, scanning the skies for potential extraterrestrial satellites, and taking a hard scientific look at unidentified aerial phenomena, UAPs. To cut through the noise, they've built a clear framework, sort every detection into 3 categories. First, natural stuff: meteors, birds, insects, weather events. Second, human-made objects: planes, satellites, drones, balloons. And third, everything else: anomalies that might carry the fingerprints of technology, such as strange propulsion, heat signatures, or flight patterns that no human craft can match. To make those distinctions, the Galileo Project relies on custom-built systems pulling in data from every angle: optical, infrared, radio, even magnetic and particle detectors. Artificial intelligence then chews through the streams, stripping away false alarms until only genuine anomalies remain. The rules are strict: only new, openly available data, only analysis grounded in established physics, and no hype or leaks before peer-reviewed results are ready. By staying transparent and avoiding classified sources, the project wants to keep its work credible and untangled from government secrecy. The timing of its launch couldn't have been sharper. In 2021, the US Office of the Director of National Intelligence dropped its report on UAPs, confirming that military pilots had seen unexplained craft on multiple sensors.
So is it? It's not moving on us, dude. Well, if there's a look at that thing, it's rotating.
At the same time, Oumuamua was still stirring debate years after its discovery, its bizarre shape and motion sparking endless theories about what it really was. The Galileo Project jumped in with a clear goal. Instead of arguing, capture definitive, high-resolution evidence that can't be hand-waved away. Funded by private donations, the team has already started building telescope arrays around the world. Systems with paired 10-inch telescopes, advanced cameras, and computers capable of sorting data in real time. They're also prepping to mine data from the upcoming Vera Rubin Observatory, one of the most powerful sky mapping tools ever built. Weekly meetings keep the effort moving, with the aim of releasing publishable results sooner rather than later. The big picture is clear. Loeb and his team want to drag the extraterrestrial debate out of the realm of rumor and into hard science. If they succeed, the impact could be seismic, on par with Galileo's first telescopic revelations. A discovery like this wouldn't just change astronomy, it would force humanity to rewrite its place in the universe.
So, what the Galileo Project is doing, that I'm leading at Harvard University, is trying to collect the evidence that will guide us.
The Galileo Project has been quietly but steadily building itself into one of the most ambitious scientific hunts of our time, mixing cutting-edge hardware with bold attempts to track down mysteries at the edge of our solar system and beyond. Its backbone is a growing network of observatories, each one packed with gear, magnetometers, weather stations, optical and thermal cameras, RF antennas, all locked to millisecond precision with GPS clocks. These stations are designed to run year-round, sealed against the elements with anti-dew coatings, heaters, desiccants, and even lightning protection. Nothing is left to chance. Starfield calibrations. Correct lens distortion, blackbody sources test the heat sensors, and cross-channel timing errors are shaved down to the smallest possible margins. The process is methodical. First, the system scrubs out the noise, stars, clouds, atmospheric clutter, so only new motion or hotspots stand out. Every detection is checked against satellite databases, air traffic signals, meteor showers, even known celestial events. Only what slips through those nets gets deeper scrutiny. Then comes the multi-channel fusion, a heat signature confirmed in visible light, or an optical trace that matches an RF ping. That's when confidence rises. The software goes further, using parallax baselines or cross-observatory triangulation to pin down trajectories. Most of what turns up gets sorted into the usual categories: planes, drones, birds, satellites, meteors. But anything that doesn't fit is logged carefully, with full error bars attached, leaving no room for hand-waving. At the same time, the Galileo Project is going hard after interstellar objects, BAISOs, an obsession sparked by Oumuamua's 2017 flyby. Loeb has long argued that some of these fast-moving visitors could be more than just rocks, a case he laid out in his book Extraterrestrial. Now, the project is preparing to catch them in real time. The upcoming Vera Rubin Observatory is expected to find several new ISOs every month once it's online, and Galileo's team is already building pipelines to analyze the flood of data. They're even exploring missions to intercept one, partnering with Alan Stern of NASA's New Horizons to sketch out probes that could fly alongside the next Oumuamua-like object. This side of the project is led by Harvard astrophysicist Amir Siraj, who has also flagged candidate interstellar meteors such as CNEOS 2017-03-09, whose unusual strength suggests it belongs to a whole new population of space debris. The most dramatic case so far is CNEOS 2014-01-08. Loeb and Siraj argued that its velocity and makeup marked it as the first confirmed interstellar meteor. US Space Command later verified the velocity data, adding fuel to the fire. In 2023, Loeb secured private funding and led an expedition off Papua New Guinea, dragging a magnetic sled across the ocean floor where the meteor was thought to have struck.
And lo and behold, we found that they have an abundance of several elements that is far beyond what you find in the solar system.
The haul included an 8mm manganese platinum wire nicknamed ISI-2 metallic shards of S5 steel with unusual toughness, and oxidized fragments they labeled red and grey. The team presented them as possible meteor remnants. But critics quickly pushed back. Manganese platinum alloys are common in lab equipment, S5 steel is man-made, and the seismic impact data Loeb used to target the site turned out to be truck traffic, not a fireball from space. This back and forth captures what the Galileo Project is really trying to do: take controversial claims and test them with real instruments, real data, and open methods. Whether scanning the skies for UAPs or scouring the seafloor for meteor debris, its goal is to move the conversation from speculation to measurable evidence. For now, much of the scientific community remains skeptical, but if the project ever lands a breakthrough, it could rewrite the boundaries of astronomy itself.
In July 2025, astronomers observed an unusual object entering our solar system.
The case of 3 I/ATLAS is one of those mysteries that refuses to sit neatly in a box. Hubble images show a strange forward glow stretching several arc-seconds ahead of the object, something you wouldn't expect from a normal comet. And yet, when astronomers looked at its spectrum, there was no trace of the molecular or atomic gas that usually screams cometary activity. That contradiction is what makes it so puzzling. What's the most reasonable natural explanation? One idea is that 3 I/ATLAS might be a dust-heavy interstellar asteroid kicking off mostly large dust grains from its sunlit side. Those grains could explain the odd forward glow. But here's the catch. Its spectrum shows reddening, which usually means small dust particles are in the mix too. Those tiny grains should have been blown backward by solar radiation pressure, forming a classic trailing tail. No such tail has appeared. Without small dust grains, the reddening would have to come straight from its own surface, hinting at a reddish, rocky body around 20 kilometers across, eerily similar to Oumuamua. The statistical problem? Objects like that should only wander into our solar system about once every 10,000 years, yet we've spotted 2, Oumuamua, and now 3, I/ATLAS, within just a decade. And then there's the trajectory. 3, I/ATLAS doesn't just tumble through space at random. It's moving on a retrograde orbit, aligned within 5 degrees of the solar system's ecliptic plane, a coincidence with odds of just 0.2%. Even more eyebrow-raising, its timing sets it up for close flybys of Mars, Venus, and Jupiter, all in sequence. The probability of that happening naturally? Roughly 0.0005%. For some, that alignment hints at something more than chance, like the possibility of a larger mothership using 3 I/ATLAS's path to release smaller probes as the planets swing by. We won't get answers anytime soon. On October 29th, 2025, 3 I/ATLAS will slip behind the Sun at perihelion, taking any potential activity, like the release of probes, out of view. For now, the debate hangs in limbo. It might be an incredibly rare natural comet with strange dust physics, or it could be something engineered. Avi Loeb himself puts it at a 4 on what he jokingly calls the Loeb scale, where 0 is a boring natural comet and 10 is definitively artificial. Upcoming observations will decide whether that number drifts down towards 0 or shoots all the way up to 10. Since its discovery in mid-2025, 3 I/ATLAS has become the solar system's newest enigma. It was first picked up by a NASA-backed telescope in Chile and, as aforementioned, flagged almost immediately as an interstellar comet, an icy traveler barreling through the solar system on a retrograde orbit at roughly 137,000 miles per hour. NASA was quick to calm nerves, stressing it posed no danger to Earth. The closest it will ever get is still more than 130 million miles away. Most astronomers see nothing unusual here. We've collected plenty of telescope data showing classic cometary activity, said Daryl Seligman of Michigan State University. Samantha Lawler from the University of Regina noted that it looks exactly like the kind of comet you'd expect to be tossed out of another planetary system, adding that its ices may only become more obvious as it nears the Sun. Oxford astronomer Chris Lintott captured the general mood, excitement about the chance to study such a rare visitor, mixed with frustration that talk of alien tech could overshadow solid science. But Avi Loeb isn't so quick to let it go as ordinary. The Harvard astrophysicist has highlighted what he sees as red flags. For one, its brightness hints at a body nearly 20 kilometers across, improbably large for an interstellar fragment. Then there's its orbit, aligned within 5 degrees of the solar system's ecliptic plane, a coincidence with just a 1 in 500 chance. Even more striking, its flyby path lines it up with Jupiter, Mars, and Venus in quick succession, something Loeb calculates as a 1 in 20,000 shot. And perhaps the oddest detail yet, Hubble images show a glow pointing forward instead of the trailing tail you'd expect from a comet. Loeb has gone as far as suggesting, sometimes cautiously, sometimes more directly, that 3I/ATLAS could be a mothership, potentially capable of deploying probes toward planets during its passage. He concedes that the most likely answer is still the boring one, a natural interstellar comet. But he insists the stranger possibilities shouldn't be dismissed outright. As he puts it, we should put all possibilities on the table until we get the evidence. So where does that leave us? To most astronomers, 3I/ATLAS is just another comet. Rare, yes, but firmly in the natural category. To Loeb, the anomalies keep the door cracked open to something far more extraordinary. And until more data comes in, the debate sits right on that edge between the ordinary and the unthinkable.
Now, I'm not claiming that it's not a comet. It may well be a comet, and we will know about it once it gets closer to the sun. We will see the cometary tail. We'll be sure it's a natural object.
In the end, 3I/ATLAS leaves us straddling the line between science and speculation. Maybe it's just another comet, maybe it's not. But as Avi Loeb reminds us, the universe won't reveal its secrets unless we dare to ask the questions others won't.